some actualities of this session, the sort of normal disclaimers that we have to run through. We are recording this session today. We're going to try to keep this fairly informal, but of course we want our two fantastic presenters to be able to get into a flow. So if there are some questions, please ask them in the chat, and then we'll have a Q&A at the end of the session. Highly recommend, as it's Friday, the weekend is almost upon us, at least I hope, for everyone that's here today. So please feel free, take some coffee and enjoy the session. A little bit about me. I'm your host for today. My name is James Wright. I've worked at TietoEVRY since January of this year as a public cloud senior advisor. I'm also a capability lead for our public cloud services tribe. I'm a huge sort of advocate and fan of agile ways of work, Scrum-like methodologies, DevOps, huge Confluence and documentation fanboy. Also huge fan of automating everything, even pursuing how you could automate documentation with enough output from code. So really kind of summarizes me in a nutshell. Before we start with the presentations from Toni and Petri, I want to talk a little bit about TietoEVRY's public cloud unit. TietoEVRY Public Cloud is focused on leveraging the best public cloud processes, policies, and tooling to make the adoption, and as we all know, this term digital transformation of our customers a complete reality. On a daily basis, we have members from team members from all over the world advocating, advising, developing, and essentially delivering solutions for our customers to take full advantage of all the public cloud technologies. Now, we leverage the power of all of the public cloud hyperscalers. This allows for a truly diverse technical environment and customer landscape, because of course, not every one cloud is suitable for every environment. As part of our daily working lives, we really try to embrace new ideas, new concepts. We love it when people take ownership, and we're always trying to promote trust and transparency. Now, it's TietoEVRY, so we do have some governance models, and of course there are structures in place, but we've designed them within public cloud to empower people rather than just slow down the kind of innovation that we want people to be part of. Now, our teams build incredible solutions, and the speed at which they do it with is fantastic. We work with solutions or platforms and technologies like Terraform. We love to talk about containers and of course things like Kubernetes. We commonly collaborate with things like Confluence, and we do chat ops with Slack. We love to commit all of our changes with tools like GitHub or even Azure DevOps. We like to share our sessions and our passions in sort of info sharing sessions on a Friday. And we really try to sort of celebrate and grow as a unit. Now, if you're excited about the idea of automating everything, and if you know your containers from your virtual machines, if you see a kind of advantage or a willingness to learn themes around infrastructure as code, DevOps, serverless, if you're passionate about making a difference in the public cloud space, please do remember that we are actually actively recruiting at the moment for both cloud advisory and cloud architect positions. You will find some links in the chat. Okay, let's get to the agenda for today's session. We have Toni talking to us about security in public cloud, and we have Petri to showcase automation in public cloud environments. As I mentioned right at the start, we will have a short Q&A moderated by myself at the end of the session. So if during these presentations and when the presenters are talking, you have some questions, feel free to put them in the chat. I'll catalog them and make sure we cover them at the end. Excellent. So I'll be quiet now because I'm really good at talking. If there is anyone in the audience who knows me, you'll know that's true of me. So without anything further, I'll pass the virtual floor, so to speak, to Toni.
There. So I will be talking a little bit about the cloud security or the lack of it. So first, some background info about me. So I'm 46 years old, located in Turku. I have a broad interest in everything related to the field of IT, and I've been doing this quite many years. Sometimes seems to be a little bit too long, and I'm not so fond of bureaucracy, and I don't know who would be. And I have a kind of deep background in Nokia, HP, Red Hat, Solida, and some other smaller companies. And I like to know a little bit on everything. So, but currently my interests are in info security, cloud, serverless containers, agile way of doing things, and just some old German cars and stuff like that. So let's start with the current landscape in the cloud. So I think that there are currently only 3 major players in the cloud sector: Microsoft, Amazon, and Google. Alibaba from China is coming strongly, but I don't think that is a real kind of threat to those 3. And Oracle and IBM too. James already mentioned Oracle, but I think it's quite marginal currently. And every player claims that they are cloud native and they have everything that you would need in the cloud. But well, I tend to disagree a little bit, because everyone is developing their stuff so on fast pace, so there might be some gaps here and there. And I think that every company currently, at least on the Nordic area, is move into the cloud or are already there. And I think the hype for the cloud and the use of cloud is more stronger than ever. And there are more inexperienced companies and players joining to the cloud, which poses some kind of threat, or more like kind of challenge for the bad guys to start exploiting those resources and companies. So that's about for the, and I think that this is my opinion, that Azure, Microsoft has the strongest cloud native security tooling currently available for the customers. And of course, Google and Amazon are developing their offering heavily, but they are still lacking at least quite a lot of those features currently available in Azure. And mind you that I'm mostly familiar with the Microsoft Azure, but I know a little bit about Google and Amazon also. And I think, well, security is kind of mindset even in the cloud, and it's a little bit different when you're doing stuff with the public cloud. You need to kind of do a, how do we say it? You need to know your stuff, or you cannot limit. You need to limit your footprint, what you show to the internet within the cloud, because it's so easy to make new services in the cloud, and that poses more attack vectors to the hackers to exploit. So I think this is at least what I have seen our customers, that is one of the biggest problems, that the companies really don't know what is running in their cloud. And when you don't know what is running in your cloud resources, or what resources are there, that you don't know how to protect those, or you don't know stuff that you need to even have to be protected. And as cloud services are developed really on the fast track, there's new services coming up almost daily. So you need to have a really fast pace to keep up. And your cloud environment is really as strong as the weakest part, because the hackers, they have time to snoop, and as stated, they don't bill by the hour, and the companies are looking at the expenses, so that as a, well, they have a kind of advantage over there. So one of the key things also when doing stuff with the cloud is that you need to have the skills. When you don't have enough skill or knowledge, you create unnecessary complex cloud environments, and complexity usually leads to errors, and errors lead to attack vectors, meaning that when you create complex environments, you don't necessarily know what footprint you are showing to the internet, and that will automatically create the attack vector for the hackers. And one of the key things that I like to talk, and James also, is the automation. And when you do things manually, it needs people, and people tend to make mistakes, and mistakes lead to attack vectors, and that leads to your company or your cloud environment getting hacked. So I think the key thing to tackle the complexity is automation, planning, and skills. I think the skills is the most important part. You need to have the right people building the environment and making the automation. Because even though the automation is created by people, when you run the scripts a few times, you can iron out the errors over there. And yeah, when doing it manually, you tend to make mistakes from time to time. But when doing with automation, you kind of iteratively can fix those mistakes. And yeah, let's talk about the bad guys a little bit. I think that currently they are more organized than ever, because there are more possible targets than ever, and there's more money to be made. So there's lots of more interest on hacking environments, and the hacking organizations, or the bad guys, they are bigger than before, and even the countries are, well, some of the countries are even in the hacking and cyber espionage, stealing data and stealing state secrets and stuff like that. And there has been already lots of custom ransomware where they are targeting a specific field or even specific companies that they use to extort money, like the medical field with the corona situation. There was some custom ransomware targeted to the hospitals. And yeah, the bad guys currently, or mainly, they have money as a motive. They want to make a fast money, and hacking some inexperienced companies as a fast way to do that, or easy way. So it's not anymore like young script kiddies who accidentally phone to NORAD as in this famous movie War Games. So the bad guys have more resources, they are skillful, and they have automatic scanning running 24/7. And as on the good side, the automation is key also on the dark side. So they are snooping the environment and environments and seeing where they can take a kind of quick wins and stuff like that. So what can you do? Well, you need to plan some more. You need to build your cloud environment foundation right, and you shouldn't make at least too many exceptions. And you really need to know what you are running in the cloud, because it's so easy to kind of build quick and fast and then forget that it's running there, and it's a quick way to getting hacked like that. So because if you don't know, once again, if you don't know what you're running, you don't know how to protect that. Access control, granular rights, that's some like basic stuff. I like to use the cloud native security tools. In Azure, there's lots of good stuff over there. And access control, granular rights, that's basic stuff. I like to use the cloud native security tools. Azure has plenty. And once again, automation. That's also on the security side. I like to use the Sentinel, which is a good tool at least on Azure side. There's lots of good stuff over there, and it can be automated, or it's automated. And one of the great things is if you want to like kind of check your environment is to organize a bounty hunt. That's a good way to test your environment or your applications or your environments. So a little bit about the development. I think that software development done in the cloud, that's one of the key things that companies are currently looking or doing or wanting to do. And that development should be taught from day one to be secure. And I think the security is everyone's job, not just the security people that are working in the company, but everybody. And once again, buzzword DevSecOps and continuous everything, but really the DevSecOps and with the DevOps is one of the key things to have kind of secure application development done. And I like to promote the SAST and DUST security unit test, automated source security scanning and the dynamic security scanning. And you shouldn't kind of just lose the pen testing if you are doing the DUST, but those in parallel is a good way to kind of keep your environment secure or sanitize that the environment is secure. And well, that's kind of the validate and sanitize input, treat all input as unsecure. That's one of the key things that we have seen that is missing some of the companies that's pointing that out, but there are a lot of other stuff, and I don't think you should like reinvent the wheel, because there are lots of best practices and development guidelines available already that you can follow, so you don't need to think everything by yourself. Well, Microsoft have a lot of documentation, also Amazon and Google also. So kind of look into the documentations and learn from there. Other things that you probably should do is follow the security scheme, because there's lots of good information there, and people are posting the one-day exploits and stuff like that, so you can kind of keep on track what is happening on the security field. That is one key thing. Probably not everybody, but at least the people who are involved in the security environment and stuff like that. And these days you cannot kind of trust that you are small or obscure enough to be safe, because the bad guys are scanning everybody, and they don't really care if you are kind of small company. They might want to take your data or inject ransomware or something like that. And one key things that you would need to do is hire the best talent, or hire vendors who are capable of doing that. So if you have the best talent, it makes so much easier to secure your environment when you have people who know what to do. So, but the hiring the capable people would be a kind of a total meet-up topic if we dig into that. And you should penetration test your environment regularly. This is something that it's so easy to kind of forget or don't do it. But I think it should be done like, well, not every month, but like 4 times a year would be something reasonable. And I like the zero trust, because it makes a little bit easier to run with the enterprise environment, at least. And the drivers for all these secure environments and stuff is, well, it's money. And there's other stuff also, the reputational damages. If you're getting hacked, your brand value will probably go down. Yeah, there's the financial penalties and the regulatory problems. GDPR, okay, once you get in the target with that kind of stuff, then you are in deep trouble and probably need to pay a lot of money. And there's the possibility of business interruption. If you're running something factories, they might get stopped, and then again you will lose money. And the litigation possibilities, the Equifax was paying $380 million in 2017 from the hacking. So it's real money that the companies are paying when you're getting hacked and you're stealing your data, and the bad guys are spreading the data. And of course, when your company gets hacked, there will be negative shareholder reactions, and the stock price will go down, and there will be other, well, again, the money is the issue then again. So to summarize shortly, you need to have, you need to plan, you need to do the cloud governance right. You need to have skills, or the people that are working with you, building your cloud environment, security environment, they need to have the skills needed for the job. Automation is one of the key thing to making these mistakes. You need to develop your cloud applications and also environment securely. And yeah, as I said earlier, the best practices are already there on the internet. So just look under there and learn tooling, cloud native security tooling. They are already there, at least some of the cloud vendors. And I cannot highlight this enough because I have bumped into this topic a lot for the last 6 months, that you really need to know your stuff, the resources that you're running in the cloud. Because, well, I have seen some cases where companies are running big cloud environments and they have no idea what is running there. So when you are doing some snooping, that what is open over there, you can find lots of potential holes, and the companies are totally clueless that they even were those. So that is something that cannot be emphasized enough. And if you don't have resources or people, or you are not willing to learn, you need to hire somebody who can do this job. It will be much easier in the longer run with that kind of approach. And well, it's not brain surgery, and I think it's so easy to do it fast and unplanned. And well, if you choose that way, it will cost a lot of money eventually, and probably some kind of impact in your brand value also. And yeah, that's about it. It was quite short one, but I think that was a kind of summary on the cloud security or the lack of it. It was a little bit doom and gloom, so it's not that bad, but there's lots of points that needs to be addressed when going to the cloud. All right, thank you.
Thank you, Toni. It was really insightful. I wrote it in the chat, but if anyone has any questions for Toni, please feel free to drop them in the chat. Don't be worried to get kind of specific. It's nice to see Toni sweat every now and again. So please feel free to ask your questions, guys. Let's move on to Petri. Petri's going to be talking to us about automation in public cloud. So this should, I'm really excited. This should be excellent. The floor is yours, sir.
Okay, let's get this started. Can you see it? Yeah. Can you see the screen already? Yeah, okay, good.
We can.
So yeah, so I'm going to talk a little bit about the cloud automation, and both James and Toni, they were referring to that quite a bit, and it's I would like to say that it's more about way of working instead of specific tools or even the cloud platforms, because it's about the way of how we do the cloud environments and what kind of things are being done there and how to keep them controlled and so on. And we got this surveillance video from Microsoft that shows how it works internally. So this is pretty much the truth today for many environments at the moment. A little bit about my background. My background is in the networking in the early days of the internet, basically building the internet here in Finland and in a couple of other places, connecting a couple of countries to the internet. in the mid-90s and that kind of things. And I moved to the cloud 7-8 years ago. Basically, we're first working with Nokia's private cloud that is quite large, over 500,000 cores in multiple continents, and then moved to AWS, Azure, and Google Cloud. So basically using all of the three. I have my preferences, but I don't really like to compare them. They have all their strengths and disadvantages. So it's they are not for everybody. I mean, they're not for well, I wouldn't use the same cloud for everything. It's all the ones have their areas where they are really excellent and some areas where they are lacking features and services. And I'm also strong advocate for basically, I guess the right word is cloud native practices, but I don't. Cloud native is so vague term nowadays that I don't like to use it that much. But basically, building everything with I like to use Terraform for everything and Ansible for configuration management if it's needed. And I like the site reliability engineering that Google invented. So basically, trying to tackle bugs before they happen, and if something happens, try to make sure that it never happens again, and building a lot of metrics that can show that the application is working, not like that you don't really want to care about the environment, you want to care about the application that it's providing the service that it's designed to do. And outside of the IT world, I like coffee. I have more barista certificates than cloud certificates. We like to travel a lot, so I don't know, 120 countries or something like that at the moment. And I like to use the tools that I talk about as much as possible because it's good to have practical understanding and experience with the things. So, for example, I run Kubernetes at home. We have had and still have bathroom lights that are controlled by pods running into home Kubernetes, and I have built everything with the Terraform at home as well. And we actually moved to an old mental institute this summer that is on the Cloud Castle Road. So I'm not sure if the results of everything or why this happened, but it's quite a coincidence that this happened. But yeah, let's get to the point. I guess many people can recognize this picture. I mean, it's pretty much what the typical enterprise public cloud looks like. They are using multiple clouds. Frequently, different teams are using. They might have started using AWS 5 years ago, and now the IT wants to move to Azure, and somebody wants to use the AI from Google Cloud and things like that. And very often, or almost every time, it's a mess from many points of view. It's mess from the management point of view. It's mess from the security point of view, and the teams are doing things differently, and there's no common practices, and there's no common governance or anything like that. So it's basically a lot of different resources running in the public clouds, and nobody knows what's going on, and there are discussions about the billing and all kind of things. And if you compare this to the traditional on-premise data centers, they had the same kind of evolution. If you go 20-30 years back, the data center was just racks filled with computers, and everybody was bringing their own there. But if you look at the data centers today, they are really organized. Everything is at the right place. Everything is color-coded. Everything is labeled. Everything is done so that it's very easy to manage. And if something breaks, it's easy to find where it is. And I think it's sort of the same thing, but it's more like a logical or software way of doing things in the cloud now. So a little bit about the toolkit or tooling that are being used. It's actually pretty simple. I would focus more about not the names of the tools or anything like that, but what you want to be doing with the tools. So first you have some kind of code or templates that define everything. So you are maybe using AWS CloudFormation or Azure ARM templates or Bicep, or maybe Terraform as a common tool for multiple platforms, or maybe you are even more advanced and using something like Publie or Cloud SDK, where you actually can use the cloud platform from the code itself. And one of the misleading terms in the infrastructure as code is the code, because it's if you look at YAML file or JSON files that are used for ARM templates and CloudFormation, nobody, especially from the software development world, calls them code. So it's basically definitions, and maybe there's some kind of possibilities to do something more advanced there. And Terraform is an example that it can do a little bit more. And when you move to Publie or Cloud SDK, then you actually have a real programming language to deploy something. And I would think that in the long term, the code will be more about managing the environment. And then if you think about the applications or workloads in the cloud, those will be managing their own resources by themselves. So for example, if you have an application, it doesn't make sense that somebody else is creating the cloud resources for that application. Why couldn't the application do it by itself? So basically having the cloud support inside the application. And which one to use? It's a bit like religion. There's no single answer which one is the best one. Everybody has the preferences, and they are different if you look behind the screen, how they work and what kind of things you can do them, and can you run them once only, deploy something and forget, or if you manage the whole environment from the code, that is more like the Terraform way of working. And the key thing is to be comfortable with the tooling that you have chosen. It's really what you want to do. It's not about the tool that you have chosen. And the second topic is who runs the code or the templates. It should always be basically the computer that is doing it. It's not something that you or somebody else at the operations runs manually. The first thing you should do to a new environment would be to build some kind of pipelines to run the code that you have. It could be empty, the code at the moment, but you have a place to run it as a starting point. In that way, when you start doing it, you already start using the automation instead of manual things, and you have basically all the construction tools available when you start thinking about the application, and you can modify it easily. And it could be Azure DevOps, GitHub, Cloud Build on Google Cloud, or AWS Code Pipeline, or Jenkins, or whatever tool you prefer to use. And again, it's more about being comfortable with the tooling and being able to use it instead of using a very specific one. And the third part is when to run the code. That's often something that is forgotten, and many people think that code is something that you deploy once and you forget about it, but it should be something that is as automatic as possible. So basically, if you change the code should run itself, and the code should be defined so that it can run itself as many times as possible. So it's not something that always needs somebody to handheld or anything like that. And of course, in enterprise environments or bigger production environments, you have to have some kind of approval processes, and those really go to the who runs the code phase, so that you have the pipeline that has approval stages and so on. And also the code should be built so that it can, for example, build development and production environments from the same code, so that you always know that you are developing and testing and running the production with the same kind of code base. And because the cloud isn't perfect, one thing that one has to remember is the configuration drift. If something happens in the cloud, is your code still up to date? So, for example, you could be running some kind of Terraform plan, for example, every day to detect if something has changed from in the cloud. Somebody went there manually through the portal and changed something, or if something disappeared for some reason, you can see that something is missing and the code must be run again. And especially with the Kubernetes environment, it's quite common nowadays to use the GitOps style, where basically if you do something manually, the automation will restore the original configuration, so you can't even do something manually there. It's the code defines exactly what is running, and the automation keeps it up to date both ways. So these are basically the three key points to remember. It's not about the tool, it's about what you want to be doing. You want to have code or templates, you want to run it automatically somewhere, and you want to have as automated execution of the pipelines and code as possible. A bit of a story from a couple of years ago with one application that was running with one customer. So basically, they had a application that was for multiple customers running in the same environment. So what they did, they had some consultants building templates, CloudFormation templates to run it. And there was multiple templates to define the networking and define the application and the cloud resources. And it was deployed to the first customer, and that was perfectly fine. And then they did it for the second customer using the same CloudFormation templates, deploying another set of all those same templates to the environment with different parameters, and everything was fine. They had two identical configurations for two different customers with different parameters depending on the customer case. And what happened next, they made manual changes to the first customer, added some resources there, and then they started adding a third customer, but people changed. They didn't know how to deploy it with the templates anymore, so they added resources manually. They started adding new resources manually, adding a third customer and fourth customer, and also patching the configurations for the first two customers that were deployed with the templates, and basically changing everything and adding new features to some of the customers because they needed something new. And again, people changed, so nobody knew what was done 6 months ago and so on. So basically what happened is that they had a complete mess that couldn't use automation because nobody knew what was deployed with what. There was a lot of deployment templates, and there was no any kind of connection which one is for which customer and what it deploys and which one has to be deployed first. And basically at the end, what happened was that the people managing this whole environment, they only had time to do patches, change configurations manually. They didn't have any time to actually look at the environment and build it correctly. And of course, this can happen. It has happened for many enterprises, many applications. And the way out of this was basically refactoring the whole thing. So what was done that the first thing was done that built the pipeline, the repository to have the code so that there would be complete source control and version control of everything, and build the pipelines, switch to Terraform from the CloudFormation templates, and use modules for defining what the customers, what kind of features and resources they would have, and then deploy those to all the customers so that basically every customer would have same kind of environment or configuration. And if they needed some new features for one of the new customers, that feature would be available to the previous ones as well. Or if they would have to change some kind of core configuration in the application, that could be easily deployed to all the customer cases. So it's something that you learn by making mistakes. And of course, all these things that happened over this 1 or 2 years when this whole thing was running is that you know what you really want. It helps to build the understanding why you want to use automation, why you want to have some kind of consistency in the code base and so on. So the key thing here is that one must be 100% committed to the automation, building everything in code, and having understanding why you want to do it in the code. You want to basically change a way of working. You want to have some kind of control of what is being deployed to the cloud instead of having the whole mess that we had at the picture for the enterprise cloud at the beginning. And so when do you want to do something with templates and automation? Of course, the sort of two common cases are building new cloud environments, new accounts, projects, landing zones, basically building the foundation for any team or any applications running in the cloud. It could be development, it could be production, but basically building the key resources that are used by all the environments. You want to have central logging, you want to have the security baseline set up, and you want to have all kind of basic things in place. So basic governance things, and what happens often is that this goes too far, so there's too many configurations, and the governance just grows too high, so that the people don't like the cloud anymore. The cloud should be very agile, very easy to use, very quick to use. If you want to deploy a new resource, you want to do it now instead of opening a ServiceNow ticket and wait 2 weeks for somebody to deploy that resource. So it's always a struggle between governance and keeping the nature of the cloud alive. And then, of course, all the applications should be deployed with the code through the automation, and it should deploy the resources needed by the application. It can build the images, it can configure the Kubernetes to run it, and pretty much all the details that are needed to run the application. And you can build blue-green environments, you can build the dev test prod kind of environment. So pretty much anything can be done with the automation. And it should be used for everything. Like, for example, myself, I'm using Terraform to build my own home environment. It doesn't make sense, but it's good to use it for something that where you get practical experience for it. And because it's running by the pipelines, it's computer doing the job, so it doesn't matter if it's running 100 or 1,000 times a day. You can run it as many times as you like. In previous life, we had automation building the AWS cloud accounts, and Terraform was running 10,000 times a month just to keep the basic governance in place. So it's so when the computer is doing things, it's very easy to scale up to as big environments as possible. And it's not only about the cloud resources. You can use the code to deploy Azure DevOps configurations, GitHub, and there's a lot of possibilities to build things outside of the cloud as well. So, for example, you could build the pipelines automatically from code that you run when you enroll a new environment. And I usually recommend that you try to forget that the Cloud Console or Portal exists, unbookmark it so that you never go there. You have to Google it, or you have to figure out where it is. And also, one thing that is quite good to have is to make access to the cloud resources as difficult as possible. If your own account has read-only access, that means that you are deploying everything more through the code, because the code is the only one that can actually deploy resources to the cloud. But of course, this doesn't always work. But for example, in one case, we had everything deployed with the code. We have support people accessing the cloud environments, and once they made a manual change to one of the accounts there, and then the second time that happened, we gave the support team basically a read-only access to the account, so they wouldn't be messing up with the automation and code base. So some basic guidelines how to do these things. The first thing is to keep everything as simple as possible. People need to understand the code. They must be able to read it. They might not have the same skills as you do. And the people are moving to different projects, and other people might be maintaining the code, or they want to do modifications there. So it must be as straightforward and simple as possible. I mean, it's the same with basically as a software development. You want to build code that is not only for you but for everybody. And in the cloud, it's very important to keep things consistent. So if you're using common modules, they should be following the same practices. If you're using, for example, Google has a lot of Terraform modules that can be used, and they are very, very feature rich. So it's good to have common practices, how to use those things and how to build them, and all the coding style, template styling practices, naming, everything should follow the same rules, so that the environment looks like that it has been done by the same people, not like that it has been done by 42 different people. And last but not least, keep it operational. Somebody needs to maintain it, somebody needs to operate it. we often talk about DevOps, but often the dev guy goes somewhere else, and the ops guys must take over the development work as well. So it must be something that people who haven't been in the same project since the beginning must be able to operate in the long term, because many of the cloud environments, they keep up and running for many years to come. So there must be something that can be used after 1, 2, or 5 or 10 years even. I mean, AWS is 15 years old, so there's a lot of time in the cloud already. And never forget the 100% commitment. So if you are using automation, if you are using code, continue to use it. Don't think that, okay, I'll do it just once and next year I will be just doing manual changes. And it's not really going to work that way. Okay, what next? Yeah, so this was mostly from the high level, what kind of automation and code and all that area, how it works. And I thought that maybe there's some people who actually use already this kind of tooling and some kind of takeaways from real environments, what kind of things can be done in the code instead of just deploying simple, easy resources. And Terraform is one example where one can actually do quite a lot of interesting things. So the first one is a simple example where we have an environment where we have a lot of network security group rules, and they are configured so that we define the rules and they are applied to the different subnets in different places. And we actually have built in validation to the Terraform template so that it checks that the
so that before it runs, it can actually check things that.
And then one of my favorite new Terraform features is the optional. So you can have optional variables, for example, in objects. So you can, and when I do some code, I tend to use it a lot. This is an example where we have basically parameters to define load balancers in the Google Cloud. And sometimes they use the Google managed certificates, and sometimes we have our own. And this is sort of how we use the optional variables from the definitions themselves. So basically, you could have objects that define almost every feature available, but they are deployed only if that parameter has been defined, and it actually makes the code looks quite interesting in the long run. And then this is about the DNS management. Often one doesn't build the reverse records to the DNS, and actually the key point here is how you can actually build automatically the reverse host name for the DNS at the lower right corner. So you can use these functions to split the IP address and reverse it and put it to the DNS name. And I'm a big fan of the for each loops. So they really make Terraform very powerful tools, because you can have for the resource key, you can have some kind of meaningful name, so you can easily update the resources. You can add new ones and remove existing ones without actually breaking anything, and it makes the resources more readable because you know where it's coming from. So I would highly recommend to look at the for each if you're not using it at the moment. And also it's something you can build them sort of dynamically inside the resources instead of just building variables with them or anything like that. So it's a very interesting way to write code, Terraform code today. And then other thing is using local variables to build logic. So you don't have to give everything as parameters to the code that deploys things. You can build quite a lot of logic by building local variables first and then deploying the resources based on those local variables. So for example, in this example, we are using Azure NetApp files, and we are building the export policies dynamically inside the code so that they can refer to the VNets and subnets. So instead of writing the IP address system manually, you can just write the name of the VNet and name of the subnet, and it will automatically fetch the right address spaces to the export policies. So it makes it possible to do code that is more resistant to typos and errors by people. Was there anything else? Yeah, that was about it. Any questions or anything?
Petri, thank you so much. I love the story. I was like that. That bit was great.
Happens to many people like that.
I mean, I've actually seen that. So I've actually seen that in reality. A lot of the customers that we have at TietoEVRY, and I think it's true of a lot of other MSPs, that they attempt to, of course, start this cloud journey, and then once, as you alluded to, once the complexities start, it can be very, very difficult when you've got different ways of working to kind of keep any sort of standardization in place. So you could end up in a kind of real chaos-like situation. So it's I think it's a story that resonates, I expect, with a lot of the people here. We did have one question from Dragon. He asked that they recently, or it's kind of let me start with a statement. So he recently started with Azure and automating environments with Terraform. He asks that, would you suggest using ARM instead going forward? A bit of a loaded question because you're a bit of a Terraform advocate, but it's there.
I think they basically, I mean, I prefer Terraform, but I think the biggest difference to ARM templates is that the ARM is quite difficult to read. It's JSON files, so it's not very readable template format. And the other one is that when you deploy ARM templates, the cloud is basically defining the state, what kind of resources you have built, and it works at the resource group level. And when you deploy something from Terraform, you are working at the resource level, so you can deploy more precisely what you're deploying. And for example, if you make changes, it's much more difficult with ARM templates than with Terraform. So, but we even actually in some environments we deploy ARM templates from Terraform because it's actually more easy to do it that way than natively. So it's for example, if you do something that are deployed only once, then the ARM templates are a perfectly fine tool. But if you're expecting to make changes and modify things a lot, then Terraform would be better tooling from practical point of view.
Excellent. I think also when we think of Terraform, what's wonderful is, of course, that they have the libraries built in for multi-cloud environments. So it can make it quite easy to, I'm not going to say it's a simple task, but if you envisage a future where you could have multi-cloud, Terraform can be a really good route to go.
And Jason was asking what I'm doing with the Terraform at home. And basically everything that I run in my Kubernetes cluster has been built with Terraform. So I'm deploying the native Kubernetes YAML files and Helm charts with Terraform, and also all the DNS that I'm running. So I have my own domain, and I have defined it in all the three platforms. So all the DNS configurations are being managed by Terraform, and then I have some of my own tooling that I use for a couple of things that are also managed by Terraform built template files. And I've been even thinking about writing my own provider for Terraform for a couple of devices because there's no existing one, but it's luckily I haven't had time for that yet. But basically it's something that I can build. I can rebuild a lot of things automatically if something breaks, and if I need to deploy something new, it's easier to do with the Terraform than start to do it manually. And it's more about building the practice to do things that way.
There was also a dialogue in the chat between Donny and Casper relating to some resources around some sort of security and public cloud specific topics. Feel free to check those links out. They're all in the chat. Casper, hopefully that helped. If there are no more questions, is it possible to share the slides? Now that is a good question. I believe that this has been recorded. I believe it will be made available externally. So the answer to that is yes. Everyone, let me take this moment to thank you all for attending here today. Hopefully we're going to have more of these meetup.com sessions in the future. Thank you to Petri and of course Tony as well for your really insightful presentations today. Wish everyone a fantastic weekend, and may the cloud be with you. I had to end on something. I mean, come on. Thanks, guys. Bye-bye.
Thank you.
Thank you. Bye-bye.